So basically, redox chemistry, oxidation and reduction, is the transfer of electrons. I am too lazy to write the word electrons, so I will do that. E with a minus sign, which I think most of you are familiar with. All right. In the past, it basically meant just reacting with oxygen, form oxides, but this has been expanded. So up to this point, well, maybe not up to this point, but all the stuff we did in acids and bases, Lowry-Bronsted, was the transfer of a proton. Now all we're talking about is transfers of electrons. Okay. All right. Oxidation numbers, which will be shortened to ON. All right, because it's a lot of words. We don't like to write a ton of words in chemistry, so we're just going to write ON. They are not the same as an atom's charge or an ion's charge. Sometimes they are, sometimes they're not. Okay, but they're not exactly the same. So there's a list of rules that we have to know. All right. So all elements in the natural state have an ON number that is 0. So in other words, sodium metal, NaS, has an oxidation number of 0. That's its natural state. Magnesium metal, oxygen, O2, what's found in the atmosphere. This is its natural state. Oxygen has an oxidation number of 0 in its natural state. It changes depending on what chemical state it's in, but it's a natural state. Monoatomic. The oxidation number equals the charge on the ion. So for example, do you know what I mean when I say mono? One atom, right? So sodium, charge is 1. Okay. Calcium, the oxidation, if I had calcium, what's the oxidation number? 2. All right. When it's a single atom or ion, it is the charge on that atom or ion. Okay. Okay. When you start to combine compounds, then things will change a little bit, but not everything. So alkali metals or atoms have an oxidation number of +1, just like they do for their charge. Alkali earth atoms, so one row over, have a charge or oxidation number of +2. That's the calciums. All right, hydrogen in acids and covalent molecules. So H2O or HCl. What's the charge on hydrogen here? And this HCl, the charge, not the oxidation number, the charge. 1, right? Because chlorine's -1. So when it's an acid or a compound, hydrogen has a charge of, or an oxidation number of +1. Okay, it's the same. If you're in a hydride, so that's where the hydrogen is negatively charged. It's the cation or the anion. So sodium has a charge of +1. Hydrogen has a charge of -1. So its oxidation number here is -1. That's a bad one. Okay. So we talked about oxygen in its natural state has an oxidation number of 0. If it's in its chemical group, all right, it changes. So what do you think it is in the chemical group? What do you think the charge of oxygen is here? Charge, let's talk about charges. What is it here? On the periodic table, what's the charge of oxygen? Sorry? -2. Oxygen have a -2 charge. So in a chemical structure of oxide, it has a -2 charge. The only time it changes is when it's in peroxides, okay? Which is, this is hydrogen peroxide, H2O2, or sodium peroxide, Na2O2. Okay, it's where the oxygens are bound together with each other in the middle. They have a charge of -1, or an oxidation number of -1. All right. Then we can use all this stuff to figure out the other atoms. So in a polyatomic group, the oxidation numbers have to equal the ionic charge. So if we have NO3 minus 1, we know that the charge on the oxygen is -2. We have 3 oxygens. So we have 3 times -2 plus, you don't have to write this out. You can just do this in your head. Plus whatever the oxidation number of the nitrogen is, I'm just going to write N for that, has to equal the charge on the molecule. What's the overall charge on the molecule? -1. So what's the oxidation number of nitrogen? It'll be 5, right? Because this is -6. -6 plus what number is equal to -1? It would be 5. Okay. So the sum, so this one is just saying the sums have to equal -1. If it's a neutral molecule, what do all the charges or all the oxidation numbers have to equal? If you sum them all, they have to equal 0. Okay. And then if you know these rules, you can figure everything else out like we did here. Okay, and that's what we're going to do on the back side. So flip the page, please. All right. You don't have to do the math that I'm going to show you. If you can do it in your head, do it in your head. What is the oxidation number of nitrogen in HNO3? So what do all the charge or all the oxidation numbers have to add up to? 0, right? Because the overall charge here is 0. What's the charge or what's the oxidation number of hydrogen? +1 in acids. So it's going to be +1 for the hydrogen. We don't know what N is, so I'll just put N. What is oxygen? -2, and we have 3 of them. And it has to add to 0. So it's basically what we just did on the previous page. 1 plus N minus 6 is equal to 0. 6 minus 1, so it equals 5. So the oxidation number on nitrogen in this case is 5. Okay? It's not always 5, though. Okay? It's just in this molecule, it's 5. All right. Oxidation number of sulfur in HSO4 minus 1. So what is hydrogen? +1. So that's the 1 for the hydrogen, plus whatever sulfur is. What are the oxygens? -2, and you have 4 of them. And they all have to equal -1. And then you just math it. S is equal to -1 plus 8 minus 1 equals 6. Does that make sense? So sulfur has an oxidation number of 6 in this. All right. Okay. We're okay with that? Okay. Oxidation and reduction. We say an atom is reduced if its oxidation number goes down. And we say an atom is oxidized if its oxidation number increases. The easy way to remember this is the same from when I went to school. Leo Ger. That's an L. So Leo lose electrons is oxidation. Ger gain electrons is reduction. So what's the charge on an electron? -1. So if you gain electrons, does your overall charge go up or down? It goes down because you're adding negatives, right? So that's why we say it's reduced if its oxidation number goes down. That means you've gained electrons. And your oxidation number goes up if you lose electrons. And in a redox reaction, you have both oxidation and reduction happening. You can't just have one, because if one element loses electrons, the other element or the other molecule is gaining the electrons. Okay? All right, I just want to do a couple of examples with you, and then I'll let you do some practice. So if we flip this over, what do I want to do? 2A and E, 3A and B. Okay, 2A. Tell me if this is an oxidation or a reduction. So you look at both sides. What's the oxidation number of cobalt here? +2. What's the oxidation number of cobalt on this side? 0. So we went from +2 to 0. Did we gain electrons or lose electrons? What? You gained electrons, right? Because we went down from 2 to 0. So is that oxidation or reduction? It's reduction because it's a Ger. You're gaining electrons. That's a reduction. So gained electrons equals reduction. All right. Let's do... All right, we'll do E. What is... Oh, so this is hydrogen peroxide. What's the oxidation number of hydrogen there? +1. What's the oxidation number of oxygen? Sorry? -1. Remember, in peroxides, oxygen has a negative of oxidation number of -1. Okay. What's the oxidation number of hydrogen here? +1, right? What's the oxidation number of oxygen here? -2. So the hydrogen stayed the same. Oxygen went from -1 to -2. Did it gain electrons or lose electrons? It gained 1 electron, right? Yeah. We're not balanced. These aren't balanced. We're not balancing these because it's a special process to balance redox. So we have to learn tomorrow probably. Okay? So don't worry about the balancing. Just look at the individual atoms. So we went from -1 to -2, which means we gained 1 electron. Therefore, it is reduction, right? So the peroxide was reduced to water. Okay? All right. We're just going to do one of the reactions, 3A and B. Okay. Look at these. We'll do A first. Determine which atom is in the reactants is reduced and which is oxidized. Okay. So copper went from an oxidation number of 0 to +2. Did that gain or lose electrons? You lost 2 electrons, right? Your charge went up. So the copper, if it lost 2 electrons, Leo, it was oxidized. Lose electrons, oxidation. So just remember Leo Ger. All right. NO3 minus. You know what the answer is going to be. If one is oxidized, the other one has to be reduced, right? Now, what was reduced? The nitrogen or the oxygen? If we look at it, what's the charge on, or what's the oxidation number of oxygen? -2. So that's -6, right? For the oxygens. So what does nitrogen have to be to equal -1? Has to be 5. So the oxidation number of nitrogen is +5 on that side. When we go to the other side, oxygen has a -2 oxidation number. So what's the oxidation number of nitrogen in that molecule, NO? +2, because it has to add to 0, right? So we went from 5 to 2. We went down, so it gained 3 electrons. Does that make sense? So if you gain electrons, you are reduced. So nitrogen was reduced. Is that okay? So what you do is you just figure out the oxidation number of the element on this side, and then look at it on this side and just ask yourself, did it gain electrons? If it did, it's reduced. Did it lose electrons? If it did, it was oxidized. That's all you're doing for those. Okay? Are we all right? Sorry? Because oxygen, in this case here, is -2 oxidation number, and there is -2. So oxidation number didn't change. Yeah. We're just looking at the ones that did change. All right, finish that page, and then we'll move on. But this is super important because this is the foundation for everything that we're going to do after this. So we have to know oxidation numbers. And I'll post the key